Hello everyone, my name is Shambhavi and welcome back to my channel Fun with Data Science. So basically in the last video what we have discussed was about the normal distribution, right? So I told you that what is normal distribution, what is the graph for making normal distribution. After that I introduced you to the z-score, that is z-score. Then I told you about the definitions, what they are used for. I even told you about some of the formulas for z-score, right? And now today we are going to see an example on z-scores, that what are the example and how do we do the things when we need to find a z-score, right? So for that, just let me choose a simple color and let's say I wanna take, okay, now let's say I wanna take red. Okay, why I choose red? Because it's the best color which is very easily, you can see it very easily, right? So that is why I always choose red. Okay, now my question for today is, suppose x belongs to n 5, comma 6. Now, in the normal distribution, I told you if something is written like x belongs to n and in bracket if something is written. So what was that? That was simply one was mu and the another was sigma. So like this was mean and the standard deviation, right? Because like in the previous video only I have just discussed the thing. Let me show you once if you have forgotten. So see here, I have written x belongs to n and in bracket mu comma sigma. So this is a thing which you have already discussed. So if something is written like this, so now just see in the example that what you got from here is that you got two values. The values for mu, that is the mean, and the value for standard deviation, that is sigma, right? Now proceeding towards the question, this says that x is a normally distributed random variable with mean mu is equal to 5. Okay, so like what it is saying, that x is a normally distributed random variable with mean mu is equal to 5. Okay, and standard deviation sigma is equal to 6. Okay, suppose x is equal to 17, then now see, this is an example. This is a very simple example which I have taken to like let you all know that how do we do the thing in this. So here, when it is written, suppose x belongs to n 5, comma 6. So after this line, this line from where it is written, this says until mu is equal to 5. So what is this? They have simply given the explanation of the simple thing which they have written, that is x belongs to n in brackets mu comma sigma. So what they were saying is that this is that x is a normally distributed random variable with mean mu is equal to 5. So the mean, that is 5, right? And standard deviation sigma is equal to 6 and sigma is equal to 6, which I have already told you. So if there was the if this line was not given here, then also you can do this question. Why? Because I have already introduced you that whenever it is written x belongs to n, so basically in bracket the first term is the mean and the second term is the standard deviation, as I have told you the you can say form x belongs to n in bracket mu comma sigma, right? So this is the thing. Now just okay, now so we have just seen this. Now let's do one thing. Simply let me write the values for everything and let's write here. So this mu is given as 5. Okay, mu is given as 5. Then sigma is the standard deviation, so this is given as 6. 5, 6, and now we also have a value of a small x. Small x, that is the value for small x is 17. Okay, so these three are the values, or sorry, these three are the values or variables, you can say. We have the values for these three. Now what we need to do is that if we want to find the z score, so what's the formula? So the formula for finding a z score is nothing much, but it's very simple, and let me write it here only. Z is equal to x minus mu upon sigma. So basically this x we know this mu, and we even know this sigma. So when we are going to put the values in this formula, we are going to simply get the formula for finding the we simply get the value for the z score. So just quickly let me do that, and I'm going to do z is equal to, and x is my 17 and my mu is 5, right? And when I'm going to divide it by 6, and now let me go a little down. Okay, so here when I'm going to 2, and so here I will be get 12 by 6, and it's simply 2. So what I got from here is that I got a z score, that is z score, as 2 when x is given as 17. Okay, so this is the thing which I got from here. Now what is my next step? Now listen to one of my things which I'm going to say, then I will tell you the, like, I'm going to write that also. X is equal to 17 is 2. Okay, just let me go a little more down. X is equal to, okay, just let me hold on, just let me erase and let me write it now more clearer handwriting. Just let me see that can I make a more neat handwriting. Okay, so just let me write that X is equal to 17 is 2 SD. Now this SD full form for SD is standard deviation, right? 2 is standard deviation in bracket 2 sigma above or to the right of the mean, comma, mu is equal to 5, comma, standard deviation is equal to 6. Now what I have written this in a two long line. So then let me explain that x is equal to 17 is 2 times of the standard deviation, that is 2 sigma, right? Above or to the right of the mean. Now why I am saying this 2 standard deviation, that is 2 sigma, because I got my z squared as 2. Now from where I am saying this, just let me quickly tell you. See, I am saying this thing from here, from this thing. See, in the last video, I told you about x is equal to mu plus z sigma, right? And after that, when we transformed, we got the formula for z square, that is x minus mu upon sigma. But this one is the real thing, right? X is equal to mu plus z into sigma. Now, quickly let me write it down here only. So, it is x is equal to mu, and I guess it's minus, right? Just let me check that once. Plus, okay, so here I am, plus z into sigma. So this was the formula, x is equal to mu plus z into sigma. So from there only I just wrote this statement. Now just pay attention towards this, what I'm saying, okay? Don't look just here and there. X is equal to 17. The value for x, that is 17. So here I have written x is equal to 17 is 2 sigma. See, I got my z score, that is z score as 2, right? And this is sigma. So from here I got it sorry, I have just taken highlighter, and just let me quickly change my pen color and let me take this one. Okay, so here I got the z value as 2, right? So that is why I am saying that x is equal to 17 is 2 sigma, 2 is standard deviation above or right of the mean, mu is equal to 5 and standard deviation is equal to 6. Now, hold on. Just let me put the values in this formula also. Now, okay, this one. So simply I will write this x is equal to mu plus z into sigma. Okay, so I have written this. Now just let me take a different color. I hope this is not clearly visible to you, so just let me take this purple. Okay, now okay, x is equal to mu plus z into sigma. Now the value for mu I have here is 5, the value for z I have 2, and the value for sigma I have is what was that, 6, right? So from here what I'm getting is that I'm getting a value of 17, and that value of 17 is my x value. And yes, this is true, because here also in the question also we were given that the value for x is 17. So from here also we are getting the same thing, right? So this is the thing. Now here I have the value for x is equal to 17. Now let's do one more test case, and now this time let me take the value of x is equal to 1. Okay, now let's say I have taken the value for x is equal to 1. Now I want to perform all the functions, like all the formulas which I was dealing with. So I would simply write z is equal to x minus mu upon sigma. Okay, so the value for x is 1. So because I have taken 1 here, minus mu is 5 and this is 6. So this is something going to result me as minus 0.67, okay, because this would be minus 4, and when I will divide it is something going to give me minus 0.67 when I'm just rounding off till 2 decimal places, okay. So this is the thing where I got the z score. The z score is this. And now when I'm gonna apply that formula, which was x is equal to, and the formula was mu plus z into sigma, right? This was the formula. So I have the value for mu. The value for mu is 5. My z score is minus 0.67, okay, and my sigma, that is the standard deviation, is 6. So when I'm gonna calculate all these things, now just let me go a little bit more down. So when I'm gonna calculate this, I will get approximate one value. So this was the only value which we have taken x for as an example, right? When I have used a test case that let's say x is equal to 11. So when I got this z score and I when just put this z score in this formula, that is mu plus z into sigma, I simply got the x value as 1. So now from here what I can say, now just let me write x is equal to, okay, I will simply write and then I will explain what I'm going to tell. X is equal to 1 is 0.67 standard deviation below or left of the mean. Mu is equal to 5. Now how can I say these things? Now just use your common sense a little bit. Let me take you to upside and where we have come. Okay, this one. So my question was, suppose x belongs to n5, 6 and we were given the value. So simply what I do, I just found the z score and after that I got the value of x. So when the value of x was positive, what I was getting is that x is equal to 17 is 2 standard deviation above or to the right of the mean. So my mean is 5. So it is above or right. That is, it is positive. And when I have taken the value as 1, so now what I am getting is that my value for this is negative. Because when I have taken x is equal to 1, the like the z score which I got was negative, right? I got 0.67. So this is the thing that I wanted to tell you, I want to convey using this example. And now just let me summarize all these things a little bit, and it's something, just let me take a different color. Okay, now let me just have a summary now. uh okay, so one more thing here. In the last example, last video only, I just told you one thing more, that z scores tells that how many standard deviation the value of x is above or below the mean. So in the first example what we saw is that it is 2 standard deviation above the mean, and in the when I have taken x is equal to 1, it was shown that it is 0.67 standard deviation below the mean. So this z score is used to convey these messages to us, that is the value above or below the mean. So I can just take a conclusion from here that if x is greater than mu, then okay, just hold on. Okay, I'm sorry. Okay, fine. Now, just let me write it in a fine way. If x is greater than mu. Now, if my value of x is greater than the value of mu, then I would always get positive z score, right? When my value of x is less than my mean, then I will always get negative z score. And when the value of x is equal to the value of mu, then I will always get a 0 z score. So the above two conditions which I have used is that when my value of x is greater than my value of my mean, I am getting positive z score. So just see, just let me go a little bit more upside. Okay, this one. See, in this, the first example which I have taken, I was having the value of x is equal to 17, right? So when I calculated my z score, I got the value as 2. And what was my mean? the value for my mean was mu is equal to 5 and x is equal to 17. So here what condition is satisfying? That x is greater than mu. So what I told for x is greater than mu is that whenever the value of x is greater than the value of mu, we are always going to get the positive z score, right? So that is why here I got positive z score. Now, in this example, when I had taken the value of x is equal to 1, here what I have done is that I have taken the value of x is equal to 1. So here the condition which satisfies is this, that the value of x is smaller than the value of mu, because the value of x is 1 and the value for mu is 5. So here the mean is greater, and whenever the mean is greater, I am always going to get a negative z score. So that is why I got this minus 0.67 here as a output, as a z score. So now I hope you got the point, the whole summary, the whole things about z score, that what is it exactly and how do we check that we are going to get positive z score, negative z score, or a zero z score. Okay. Now quickly once again let me revise that what the z score does. So z score tells that how many standard deviation the value of x is above or below. So when we are going to give the z score as positive, the value will always be above and in the right hand side. Okay, but when we are going to get the value of z score as negative, so my whenever I'm going to get the let's say whenever I'm going to get this x is smaller than mu, then always I'm going to get the value of z score below and towards the left. And whenever I'm going to get this x value greater than mu, then always I'm going to get the z score above and towards the right hand side. So I hope I made this thing clear to you about the whole z score, what's the concept, and how do we simply apply this formula and find out the z scores. Okay, and how do we check about the negative and positive things. So I hope I made this all the things clear to you, and if you have any of the doubts, you can just rewatch the videos or ask me in the comment box. And don't forget to like, subscribe and share the channel. So this is all for this video. Till then, thank you and bye bye.